Assalamualaikum warahmatullahi wabarakatuh. So today we will talk about secure data transmission system using enhanced Viginre Cipher. So basically our project is Viginre Cipher. So what will be in this slide? So we will talk about what is the Viginre Cipher, why Viginre Cipher is being chosen, what does Viginre Cipher support, and problem and objective of our project. So what is Viginre Cipher? The Viginre cipher is a classical encryption technique that uses a keyword to encrypt a message. It is a type of polyalphabetic substitution cipher. Why Viginre cipher? So it is to improve security over simple cipher such as Caesar cipher, uses a keyword instead of a number, hides letter frequency pattern. It is simple but powerful, flexible and suitable for real-world data handling. So what does Viginre cipher support? So it supports encryption and decryption, text or file-based input and output to screen or file. So what is the problem and objective of this project? The first question is why securing the data transmission is necessary, and what is the aim of this project to achieve? So why securing the data transmission is necessary? First, it is to protect privacy such as messages, personal and sensitive information, to prevent data theft such as bank details and online password, to ensure data integrity, to prevent unauthorized access to data, and to avoid legal and financial problems such as legal actions and unauthorized withdrawals. So what is the aims of this project to achieve? First it is to design and implement a text encryption and decryption using C++, to apply a keyword-based encryption approach combined with numerical seed, to convert encrypted data into hexadecimal format for safe representation, to support both text and file-based input and output, and lastly to demonstrate basic concept of data securing, file handling, and modular programming.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal. In this video, I will briefly explain the algorithm of our encryption and decryption program using a flowchart. First of all, the program starts by displaying a menu where the user can choose to encrypt, decrypt or exit the program. If an invalid choice is entered, the program returns to the menu. This looping process continues until the user decides to exit. After selecting encryption or decryption, the user chooses the input source, either text input or a file. If a file is selected and cannot be opened, an error message is shown and the program safely returns to the main menu. The program then asks the user to enter a keyword and checks that it is not empty. A numerical seed is also entered to add variation to the encryption process. Next, the program generates a repeating key based on the keyword and seed, ensuring the keyless matches the input text. If encryption is selected, each character of the text is combined with the key and seed using ASCII-based arithmetic, and the result is converted into hexadecimal format. For decryption, this process is reversed to recover the original text using the same key and seed. Finally, the user chooses whether the output is displayed on the screen or saved to a file. Thank you. That's all from me.
Assalamu alaikum wa rahmatullahi wa barakatuh. Now I'll briefly walk through our C++ implementation. The code is structured in a modular way, where each function handles a specific task, making the system easier to understand, debug, and maintain. The process starts with the generate key function. Instead of repeating the keyword directly, we use a numerical seed to calculate the starting index. This means even with the same keyword, changing the seed produces a different key sequence. During encryption, each character is shifted using the key and the seed with modulo 256. This allows us to support the full ASCII range, including symbols and spaces. After encryption, the output is converted into hexadecimal. Each byte becomes a 2-character hex value. This avoids issues with non-printable characters and ensures the encrypted data can be safely stored or transmitted. The reverse process converts hex back into bytes during decryption. To improve reliability, the program includes validation checks. For example, it detects empty keywords or file errors and safely restarts the menu instead of crashing. The system also supports full file input and output, allowing entire documents to be encrypted or decrypted efficiently. That concludes the code walkthrough. I'll pass it on to the live demonstration.
Now, let's see how the programs work. As you can see, our programs include three main functions. First, encrypt, second, decrypt, and exit. So first, we will encrypt a simple text message. How to do that? First, we must choose option 1 to encrypt. And then we choose 1, input 1 for text. Then we must enter our text here. Now I will copy this and then paste. And then for security layer, we added a keyword and a seed. Our keyword is comma here, and then seed is an integer. With this, the result will be the encrypted text will be generated in hex format. This ensures that even non-printable characters are stored and transmitted properly. Now I copy this, and then to make sure this programming is working, we must make sure it is reversible. So then we choose decrypt option 1 for text, and then we must enter our text here. And the text is the result of the encrypted text. And then we must enter the exact same keyword. And then the seed 1983. Output to screen. As you can see here, the text here match perfectly with the original text. So it's working. Now I will show how these programs work with file encryption. So first we must include the file in the same folder as the source code. And then we run the programs. After that, we do the same thing, encrypt input from file, and then we must enter our file name. So our file name is vte.txt. Enter, and then the keyword is this, EC1313, and then seed 2025. And then we can output to file. Output file name, encrypt to decrypted. Same as before, but only to encrypted to decrypted. And then when we open the file on the folder, we can see this here, encrypted decrypted. And when we open this, I don't think we will need to open, but anyways, let's open it. This is the hex format. Then we go back to our terminal. We run the decrypt, input from file, enter input file name, encrypted.decrypted, enter keyword, same as before, EEC1313, enter seed 2025, and then we can output to file. Enter output file name, let's do it as already decrypt.txt. Save to file successfully. Then we exit. Alright, then as you can see here, this is the file already decrypted. The message is perfectly restored.
Bismillahirrahmanirrahim. Assalamualaikum. So I will be presenting this section that focuses on testing and results. Basically, it is an observation, and its aim is to verify correctness of this program, validate all features such as inputs and outputs, handle errors, and prove its reliability. First of all, we test the correctness by encrypting and decrypting the text using the same keyword and seed. The decrypted output matches the original text, which confirms the algorithm works correctly. So it means it has correct encryption logic, has working set-based offsets, and accurate hex-to-byte and byte-to-hex conversions. Next, we validate all features including text input, file input, screen output, and file output. The program also has function identification, and it proves that it handles implemented input and output handling. We also test error handling. If the input file does not exist, the error message is shown and the program continues on running. When the input is empty, such as the text input or the keyword input, the program displays a warning and safely returns to the menu. We also test decryption using the wrong keyword and seed. In this case, the output becomes corrupted and unreadable, which is expected behavior. Also, during the decryption, if the hex input is invalid, the program rejects it to prevent corrupted byte processing. Unlike the wrong keyword and or seed section we have seen just now, it depends on the incorrect decryption key. For the hex input, it depends on the incorrect data format. So this whole error handling confirms that the correct credentials are required to recover the original text. Throughout all the tests, the program remains stable and does not crash. So in conclusion, the testing results show that the program is correct, reliable, and handles invalid input safely. So based on what has been observed, the program has no crashes, no infinite loops, no memory corruption, and program continues running after errors. Thus, this program is reliable and safe for repeated execution. Thank you.
So to finish up, this project shows how we can use C++ to make a system that keeps data safe using a stronger Viginre Cipher. It's really useful because it can handle not just the normal text, but also all kinds of characters and even figures. So you can protect different types of data. The number of VI to the keyword makes the encryption stronger because even if you use the same keyword, different numbers give very different results. Also, changing everything into HEX makes sure the encrypted data can be safely stored or sent to another computers without any problems. Overall, this program makes the older cryptography adheres without modern coding, giving a system that is flexible and safe and easy to use. Thanks a lot for watching, and I hope this demo was helpful and clear.